Rotations and reference angles. This will wrap up 5-1. Rotations and reference angles. So an angle can rotate. So if I say this is quadrant 1, and this is quadrant 2, and 3, and 4, just like from Algebra 1 class, and we have an angle, let's say this, that opens up this way. Okay, this would be going counterclockwise. Counterclockwise. So if it's counterclockwise, that's what happens when I try to write in the morning. Clockwise, the angle is positive. Okay, positive. So I'll put the yellow that way. Now if we have, say, a purple, and this angle maybe ends up down here somewhere, and this thing opens up this way, which would be clockwise, this angle swings open like that. Well, that's moving in the other direction, and that's going to be a negative angle. So if it opens clockwise, it's a negative angle. And so that's why some angles are positive and some angles are negative. So that part you have to know. And you have to review and remember which quadrant's which, because there's a bunch of rules for this, dealing with reference angles. But I'm going to try to make those rules very, very simple for us. Just remember that the way these angles swing open is super important to what their degree is. Now, a little bit of vocabulary. If we have an angle like this, and let's say this thing swung up like that, this would be called a little bit of vocab, initial side, and this would be called the terminal side. So the end of the angle is called the terminal side, and where it starts is the initial side. And if you ever hear, if an angle is in standard position, that's what that means. So if it ever says standard position, that means you have a terminal side and an initial side. And of course, this right here, this elbow of the angle from geometry class, is called the vertex. So that is called the vertex. So just a little vocabulary for you, no big thing. All right, now let's do some problems. Okay, get that all the way off there. Let's say we wanted to know what a 1.75 rotations counterclockwise was like. Okay, so what I'm going to do, I'll draw a little XY axis for both of these. Now I'm going to overkill my amount of work here for this demonstration, but it'll be good. So 1.75 rotations counterclockwise. So you tell me, counterclockwise, is that going to be positive or negative? Positive. So 1.75 rotations is going to go all the way, whoops, let's get rid of that. It's going to go all the way around once, and then going to go 3/4 of the way around again. Okay, so it's going to go around again and stop right there. Okay, so it's kind of like when you see the skateboarders or the people doing backflips or something like that, and they have 2 rotations, how many degrees is that? Well, it's pretty simple, and you don't really need to think about graphs on this. It's just 1.75 times the amount of degrees in a circle, because we're talking rotations, which is 360 degrees. So if you take 1.75, I should have already done this, but I didn't, 1.75 times 360, well, that equals 630 degrees. And then you just have to figure out if it's positive or negative. And it's positive. Okay, let's do this one. 5.75 rotations clockwise. Well, think about it. Clockwise is going to be positive. This is positive, remember, and this is negative. So it's going to be positive. So you just do 5.75 times 360, and you get some giant number. 5.75 times 360 is 2,070. So if you could somehow do a basketball slam of a 2070 degree spin, you would be spinning 5 3/4 times around. Okay? Which would be a lot of spins. Now, there was a little boo-boo I made here. Sometimes that happens. These are backwards. I apologize. This is positive. This is negative. I just, it is backwards, and my brain did that, and so will yours. That's why you have to think about that. It's so easy to screw up, so I just demonstrated how easy that is. But if an angle rotates clockwise, that's this way, that's going to be a negative angle, and if it rotates this way, which is counterclockwise, it's going to be positive. All right, so instead of redoing this whole video, I think we're good. I think I said everything right. I just wrote those blue things wrong. Just to review this right here real quick, you just take the rotations times 360. You figure out if it's positive or negative, and boom, done. Okay? Next, a little bit more involved on this, and I'll try to get this done as quick as I can. Let's say we want to find what's called a reference angle. Okay? I have kind of an easy way to do this, but it might be a little bit difficult to get a hold of the very first time you see this. So let's say we have negative 284 degrees, and I want to find what a reference angle is to that. Well, I always like to visualize. I like to connect the picture to the math. Is this thing going to open clockwise or counterclockwise? Clockwise. So it's going to go this way. Okay. Now, if it's going to spin open 284 degrees from this initial side here, remember, this is the initial side, and it's going to start spinning. How far does it spin? Does it spin all the way around? No. In fact, remember, this would be 90, and this is 180, and this is 270, right? Because these are all 90-degree angles. This would spin just a little bit past that. So it would go around and maybe stop like right in here. So this angle would be, say, maybe like that. This would be a negative 284 degree angle. Now the question is, what is the reference angle to that? And the way I look at this, and you can do this every time, so draw your little picture when you have to do this. Figure out where that final or terminal side is, and then take the tip of your arrowhead and go straight down to the y-axis or to the x-axis. So connect the arrowhead to the x-axis, no matter where it is, and then figure out what that angle is right there, what this angle is right here. So let me ask you, what would that be? Well, this is kind of tricky to try to figure out, how far past the 270 did it spin? So in other words, it spun all the way past the 270 to here. So what would this red angle be? Well, it would be 284 minus 270, which would be, 14, right? 14. So this angle here, because they're complementary, this yellow angle would have to be what? Well, if this is 14, what would this be? Because they have to add up to 90. This would have to be 76 degrees. So the reference angle to negative 284 is 76 degrees. Now, a lot of people, the first time they see this, are like, oh, I don't know if I got that or not. Let's try this again. 500. Now, I picked the tougher ones here. 592 degrees. All right? You tell me, clockwise or counterclockwise? Counterclockwise. So this thing is going to go 592 degrees. So let's look at that. 592. Now that's definitely going to be more than one spin. So we're going to subtract 360 from it. That'd be 232. So this thing is going to basically go one whole spin plus another 232 degrees. Now remember, this is 90. This is 180. This is 270 going this way. So this would go around to maybe not quite to 270, maybe to like right there. Okay, that would be our terminal side. That would be our terminal side. Now remember the rule. You take the tip of the arrowhead and connect it to the x-axis. Bring it straight up. Straight up or straight down. Never connect it to the y-axis, ever. You will miss it for sure. So connect it here, and then you're trying to figure out what that angle is right there. The angle that's opposite this green side here. You're trying to figure out what that angle is. So let's try to do that. This is 232. Now, 232. So it goes past the 180 how many times? Well, that would be 232 minus 180, which would be, let's see, carry the 1, that's 52 degrees. So this angle right here would be 52 degrees. The reference angle, therefore, would be 52 degrees. And let's remember, reference angles, always positive. Your final answer should always be positive, and because it's always this angle right here. Okay, it's always that angle. Now, if you need to watch this again, feel free. I know this has been a long video. We're up to 11 minutes. I need to stop this. Have a good one.